I would like to welcome Mr. Chandan Sharma. Chandan is Senior Associate at Cognizant Technology, and he would be delivering an interactive talk session on Jarvis in Act, AI powered self healing performance suit. So, to know more about Chandan, you can go to the below link. Yeah, Chandan, it's over to you now. Thank you.
Chandan, are you available? Can you please come on camera?
Yeah,
Stop
I'm
sharing.
available. Hi. Hi, everyone. I'm just going to. Hi, I hope I'm visible. Yeah. Um, Hello, everyone. So, thank you for joining me at this event. And my session today is about the AI powered self healing script or the performance suite, actually. So, I would start by saying sorry, as the topic is like ideally a solution, and I should have gone with showing a demo or like going with the lab session. But since it is still in development phase and there are like few more areas which we need to like tweak and develop, that's why I just went with this interactive session. So yeah, over the next few minutes, we will explore on how AI and automation are like upgrading performance testing in modern DevOps environment. So before that, let me just quickly share my screen, and then I'll just show you what exactly I was talking about. Okay. Uh, I hope the screen is visible.
Yes, Chandan, we can see your PPT. If you can make it in the slideshow, probably it will be readable as well.
Yeah. Okay. So just to give you an overview, right? So the brief idea about this solution is like how we are going to utilize the automated DevOps and the AI or ML technique, which is like trendy at the moment, and how we can make the performance testing like easier, faster, and reliable. So basically, when I say we have to make the performance testing like automated and it should be capable enough to like self heal, I basically talk about the intelligent ecosystem that is a rule based engine which we have created, and that actually integrate well with the AI and machine learning, right? So uh, these both combined make the performance testing like actually not exactly the performance testing but the phases around it very fast and adaptive, and then like it is less dependent on manual intervention. So the suit ideally automates the discovery phase, like the user discovery phase. It self heal the scripts whenever like there is any application changes or any payload changes, and then it also provides a detailed report from client and server side both, along with the root cause analysis. So that's a brief idea on like what exactly we are going to go through this session. And then let me just quickly brief you about the traditional performance testing approach. So what exactly is this and why we need it? I mean, that I don't think like we need an introduction about it, but again, just to give you an overview, right? So let's take a step back, and we will discuss about these phases and like very brief. So when we define, or like we will have to go ahead with the requirement analysis phase where we define the SLA and KPI, just to extract all those information for any performance delivery project. we create a test plan, test strategy document, and then like we'll have to go ahead with the scenario creation. Once that is done, we develop our script, that is the performance script we call it, and we will have to fine tune it. We have to provide the test data and all, and then like we go ahead with multiple load testing scenarios or like endurance test, whatever is planned as part of this strategy. And lastly, when everything is done, we go ahead with the reporting part, and then maintenance comes into the picture where the self healing will kick in. So uh, in the traditional world, the maintenance part is more of like, let's say you go ahead and test any particular application, and then there is changes in the application payload, or if there is any change in the endpoint of the application, we will have to come back to our script and then like fine tune it again to make it like working for those particular changes, and then um, go back, execute tests. So this is the traditional approach we normally follow in the current scenario. But when we say about these traditional approaches, right, so each phases has this like own limitation. And here what I've done is like, just from the solution point of view, I have picked three major pain points that are like time consuming and resource intensive. So the first one here is about the script development. Obviously, that is the major one. So now, right now, what we are doing is like we have to go ahead, um, identify those user journey, the positive and negative scenarios and all, and then like we will have to go ahead with the manual reporting, the correlation part, identifying those dynamic boundaries, and the parameterization, and then like we'll have to upload or integrate the test data with the script in order to make it work. Right, so all these manual activities are like literally time consuming activity, and again like it requires a lot of smoke tests to be executed in background to make it work. So the second one here is about the script maintenance part. So obviously, as I mentioned earlier, right, so
Sorry,
uh,
Chandan, just want to say, are you showing the first slide or a different slide? Because I'm able to see only the first slide, which is your introduction.
oh, is it common for everyone? Because I can
Yeah,
see it.
then actually you're not sharing your PPT. It's not on slideshow. You can say that.
Yes, Chandan, you need to
Yeah.
put it on the slideshow, and then only we'll be able to see it.
Chandan, when you share it, the same screen that you were showing, below you will find a slideshow. If you can share it again.
Mhm. Let me share the entire window. I'm not sure if that's an issue.
Yeah. Yes. Yes. Thank
Can you
you.
see my screen now?
Yes. Yes.
Yeah, thank you.
Okay, just go to the presenter view. Okay. Sorry. Okay. So far, what I have covered, I mean, like what I was talking about was the overview on like what exactly the solution is about. And then I covered the phases, different phases of the traditional performance testing. Um, and now I'm at this slide. So hope this is visible for all of you now.
Yes.
Yes, it's fine now. Yeah.
Okay.
Yeah, but this
Yeah.
still
So,
shows on the. Can you click the fourth link from the left hand side? The fourth icon. Yes. Doesn't allow you. Okay. Okay, fine. Go ahead, Chandan. Thank you.
okay. Okay. Fine. So yeah, what I was talking about is like these traditional approaches and the limitations around it, right? So um, I already talked about the manual scripting challenges, and then like the script maintenance part, right? So as I mentioned earlier, like whenever there is any testing changes, or like whenever there is like any application changes or infrastructure changes, right? So we'll have to go back and debug our script what we had developed earlier, and then we go ahead, apply those changes, maybe apply new correlations technique and on that, and then like we'll have to go ahead with the execution part. So that's the script maintenance part. And the last phase, which is again like tedious job for us, which is result analysis, right? So here in this part, we ideally collate all the information whatever we have gathered from the execution phase. So we have to collate all the client side performance metrics, and along with that we'll have to go ahead and collate the information from the server side as well, provide a detailed observations, put together like all the suggestions whatever we have it from the performance side, and then prepare a complete manual report which can be shared with all the stakeholders and developer, right? So these are three major key areas I have picked it up for this session. And when we talk about these traditional approaches, right? So these were working like from so many decades at the moment, right? So why exactly it is failing now? um, all of it like was working fine until past few years. So what exactly changed, and why these limitations are coming in? And the very reason, or very easy answer would be the advanced or the complex architecture we have it at the moment now. And along with that, it has been facilitated with like several complex APIs or microservices. Along with that, like there are so many rapid CI/CD deployments going on in any project or in any account, right? So due to all these challenges, uh, the approach which we followed in past, now they create a very bottlenecks, I would say. It slows down the complete DevOps workflow. And again, like since whatever activities we have to do it as part of performance testing or engineering activity, right? So that ideally delays the overall delivery timelines as well. uh, on top of it, whenever we do these reporting activities and all, right, so that is also something very resource intensive, and we need uh, an expert to be available all the time, who will, I mean, who actually provide all the recommendations and observations from those specific test executions. So uh, what is the solution? So now, since we have like enabled with AI and ML, right? So why not we use it and see like how far we can go with that? Now what we have done is like since initially itself I told like we have segregated these things in three phases at the moment, right? So the concept and benefit, we are going to get it out of those three phases, and like how we are going to implement the automation or the rule based engine, and again like the AI or ML into each one of the phases, will basically show you, or like will basically help you understand on what we have done so far. So when we talk about the first phase, or the first part, which is pre-setup automation, so this basically will help you to auto generate the script. So whatever activities we were doing manually so far, what we ideally have to do is like it's very simple when you see from a automation point of view. So we already know about crawlers, web crawlers and all, right? So these crawlers, what they will do, they will ideally do is like they will help us identify the user journey, right? So when we have those information, so what ideally we do is like we create a JSON structure where we will provide all those information for the crawler to use. Let's say if you have any input field where you need to pass on your username and password in the web page, we will provide all those information in the JSON structure. We will pass that, or we will use that JSON as an input for the crawler. And what the crawler will do is like it will eliminate all the manual steps of recording, and then it will create a har file for you. So it will go through the website, and in parallel we will record the har file. The same har file we can use it later on for the scripting purpose and all. But before that, what exactly the role AI plays here is like we we have utilized the NLP capability, and along with that we have the graph algorithm also, which will basically which what it basically does is like what basically it does is like the natural language processing will help you identify the mapping, or the navigation, I would say. It will help you identify the performance scenario for you. So let's say we have to deal with normally, like what we do is like whenever we go ahead with the recording part, or like whenever we decide about any scenario, we identify, or we try to identify with the positive ones, so that whenever there is any performance issue there on those positive scenarios, we easily identify them. So this NLP, it will actually help us to identify those scenario or the user navigation, and then based on that it will create the JSON structure as well. So it will pass on all those information in the JSON, and then the same JSON we are going to use it in the crawler as well. So by this method, ideally, what we are going to do is like once we have the once we have the har file generated, we will just deploy that in whatever tools we are using. Let's say it is Neoload, JMeter, LoadRunner, and then that har file can be later on utilized for this script generation purpose. And then again, the AI will be used to identify those dynamic values, dynamic boundaries, I would say, to help us with the correlation techniques, to help us with the parameterization technique. And then the script will be partially automated, or in such cases it can be, or in some cases it can be fully automated as well, right? So those are like, let's say if we have just the APIs to be scripted, in those areas we can actually go ahead and create a fully working script which will help you to execute any tests whatever you want. Now when I described about the process and all, right, so this is what I was talking about here in this architecture, right? So as I mentioned earlier, we are going to use the web crawler method here. Ideally, we do have an option to switch back to the Selenium script as well, which is already available, since it is going. Obviously, the non-functional requirements will come after the functional one, right? So since we already have the Selenium script ready, we can either use that, or else we can use the web crawler method. And then using that, we will generate the har file, which will then get converted into the Neoload scripts. Here in our account, we are using Neoload, so that's why I have used Neoload here. So once we have that script, we can use that as like rule based correlation and parameterization, which we already have. And then the added advantage the NLP and AI is going to provide us here with the dynamic identification, dynamic boundaries identification. So that's how we are basically creating or developing a script, generating a script actually. And then finally we are going to pass that as a output to the Neoload web for further executions and all. So this is part one. In part two, we will talk about how we are going to achieve the self-healing scripting, right? So I have already mentioned like what exactly is this, and why we need it. So there can be any changes in the environment. It actually doesn't matter, and when it changes, right? So we will have to go back, change the script, update the scripts accordingly, and then provide all those parameters, correlations into the script, and then make it ready for the execution part. So when we talk about the architecture of this, right? So this is going to be our performance script, and we do have our tester data here. So the self-healing engine, this actually is uh, this actually is getting divided into three different segment. So one is monitor, which will ideally monitor your execution part. It will identify where exactly your script is failing, and then based on that, it will pick up the healer part. So the second part here in this uh, self-healing engine is the healer, which will go ahead and utilize its capability and then fix those areas wherever we have seen those issues. So that's the second component of it. And the third component, which is available here in the healing engine, is the learning capability. So with the help of machine learning, right? So what we have achieved is like it will go back and look for all those, or it will actually read through the past um, issues whatever we have foreseen, and then based on that it will repeat the same steps again and again. It will keep all those information for the record, and it will actually help make this engine more efficient, and like over the time it will give you a more accurate results as well. So then we do have AI ML model as well. Again, like this is going to be utilized for the parameterization and correlation of those specific dynamic values, which is like failing now. So we will utilize that, and then with the help of specific models like TensorFlow or MLflow, we will provide those inputs back to the self-healing engine, and then it will go back to the scripting performance script which we have created as well. So this is the whole architecture which we have designed for the self-healing part. And obviously, like when I mentioned about the monitoring and logging part, right? So that is one of the component, and along with that, we do have a notification service which will serve as the learner part. So it'll ideally keep a log of everything, and it'll keep notifying the engine about like what has changed and how we are going to rectify that. So that's about the second part. And the third part here, which I had mentioned in the manual part, was the automated reporting, right? So uh, since the execution is completed, what client expect is like to provide the report and very tangible timeline, I would say. And again, like we will have to give all those information in a very short time. So when we need to deal with all those shorter expectation, right? So what we have done here is like, since all these raw data and the client side data, the server side data are readily available, let's say, uh, for sake of an argument, we have utilized neoload here, right? So the neoload, and let's say from your server side, app dynamics or dynatrace, we do have all these, all the apis available from the dynatrace point of view, and again from the neoload side of view as well. So neoload provides a list of swagger apis, which will ideally help you to extract all those raw information. And then we do have, let's say, from the app dynamic side as well, each of the server element has its own set of api key, which we can use, and then provide a detailed report or collate those information from these specific tools, and provide our observation out of it. So when I talk about the architecture of this, so it definitely provides or collates the information from neoload, as I mentioned, and then server stat. Uh, After that, once we have the raw information, we will utilize or we will use a parser, which is a Python based parser, just to extract the raw results and analyze them. We do have a capability where we are storing all those test data, and then there is an analysis engine, which will analyze the complete results, whatever we are going to gather it from the client side and server side. It will provide its own recommendations and observations, whatever we have seen over there in the execution part. And then with the help, obviously, I mean, this particular engine, it is powered by OpenAI. So with the help of that, we are providing all these information to the client. So uh, with the analysis engine, there is one more advantage of using it, is like it will provide you a detailed summary of what we have seen. So not necessarily you'll have to deep dive into the raw result. I mean, the manual intervention of analyzing all those data, that can be eliminated, or at least it can be covered around 70 to 80% of the phases, where we can eliminate those manual intervention and provide a detailed reports, right? So uh, that reporting will then go into analyzed UI, I would say. So that is a advanced HTML based dashboard which we have created, and it will provide you all the graphical representation of the client side and the server side data. And then once we have all those information, right, we have integrated machine learning algorithm as well. So what this will do is this will analyze all the results, whatever has been captured so far, and then based on our historical data or historical issues data, I would say, uh, it will provide a recommendation as well, that let's say if something has failed, any of the any key performance metric has failed, right? So it will look into the historical issues or historical data. It will try to find out, or it will try to debug it on its own, and then it will help developer to fix those things, or at least even if it is not going to fix them, it will help them find a fix for it, so that they can go ahead and work on it. So this is a holistic view of the third part, which is the recording, which is the reporting and observation. So this is what the solution is about, and on a very overall architectural diagram, if I show you, right? So this is what it looks like in a complete DevOps environment. So all the three phases are integrated with each other. And let's say we get an entry from Jira about any of the project, right? We have the NFR with us. So what ideally we will do is we start working on the test planning, test strategy, and then earlier, as I mentioned, right? So either we will utilize the Selenium script as an input, or else we can use the crawler as well, which will create the har file for you, apply a predefined template, or I would say a predefined rule based correlation or parameterization, which will generate the script for you, upload that script to the testing tool, and then from there we will execute the test, go ahead with the result analysis part, and then from the result analysis part we can go ahead with the observation and the defect triaging part as well. So this is what the complete DevOps looks like, right? So the next one is what business impact or what benefit we can achieve from this, right? So obviously when we have these kind of DevOps environment, or the automated solution, right? So uh, definitely the timeline is going to be a major impact in the overall delivery side. So we can make the testing cycles far more faster, and um, the maintenance effort, or the accuracy we can achieve a very improved accuracy we can achieve. And then like from the reporting point of view, we also have a unified single dashboard, and again like the ROI can be measured, right? So these specific benefits we can achieve out of it. Obviously, uh, this is not 100% automation or AI based automation, I would say, but at least from the business point of view, or the from an engagement point of view, right? So we can say that at least 50 to 60% of our effort can be reduced. From the cycle point of view, of from the delivery point of view, we can at least fast go for a 40% faster test cycle. And again like since we have all these capabilities where we will maintain our records, or we have the database as well integrated, which will keep track of all those historical data. So from the maintenance point of view also, it is very useful. um, so yeah, this is what all about the solution, I would say. Maybe next time the complete picture will be ready, and I would show the complete demo to you. But yeah, I think we still have a few more minutes left. If anyone has any question on it, please feel free to ask, or else like you can drop it in a chat for me
We
to
have
pick it up.
we have a couple of questions,
Yeah.
Chandan. What are the biggest challenges in implementing these AI workflows? I think this was during your other presentation slide.
Yeah, so major challenges, what we have faced here in this, I mean, in the current setup, I would say is like, since this whole activity was a part of our own account, right? So um, getting all these things in place, like the Copilot access, or the OpenAI access, those were the major challenging part. But uh, once we had those available, it was like very easy for us to implement all these things, because what we used is like we have used the capability, AI capability itself, and that helped us developing all these things, all these utilities, I would say. So the major part was the infrastructure setup itself. But once we had that, it was quite easier for us.
Okay, thanks for sharing
Is
that.
there any
Yeah.
is there any sample Git repository, or is there any prototype where we can see the implementation? We are glad we understood the concept.
Yeah, so I mean, at the moment, as I said, right, so this is more of a account label activity which we have done so far. But I mean, I'll check that around if that can be uploaded or can be shared on a public Git repo. I'm more than happy to go ahead with a demo actually, but um, I'll just have to check on that, and then come back to you with the repo part.
Sure. Sure.
Another question, Chandan. How does Jarvis differentiate between environment level issues and application level performance issues?
Right. So it is not going to be taken care by the AI or Jarvis, I would say. But what we have done is like it's a rule based, more of a rule based engine. So we are basically pulling those data with a Python script. Uh, so when you say the client side reporting and sorry, the client side data and the server side data, right? So we are individually pulling them out with the help of APIs, and then the Jarvis, where exactly it is acting, is like it is acting on the recommendations part, or the uh, defect triaging part. So that is not analyzing the or that is not different categorizing it from the application side and the server side, but it is basically helping us to understand what exactly is the result, what are the observations, what recommendations we can provide, and let's say in some scenarios what are the fixes for those particular things, for those issues and all. I hope
Sorry,
that answers your
I
question.
was talking on mute.
Yeah.
How do you track requirements which are the source of truth?
Right. So that is one more phase which we are planning to do. So what we are trying to do here is like, um, right now, whatever NFRs we are collating, right? So all of them are completely manual. We will have to go ahead with all those manual steps, but we are trying to build a chatbot, which is basically um, powered by the ML. We are trying to actually provide all those information for a set of application, for a specific application. Once, let's say, let's say for a cloud based application, or more of a generic application, you have all those infrastructure requirement, and how exactly your application runs, right? So we are creating a sort of document which contains all the NFRs from past project, and we are going to keep that into a document. We are trying to train that ML model and then utilize that ML as a chat bot as well, which is going to provide you the NFR in like this complete solution. So that will help you um, generate the NFR in an automated way, Dipti. But again, at the moment we are doing this completely manually, the
Okay.
NFR part at least.
Okay. You can probably stop sharing the screen,
Yeah.
Chandan. And also, there is one more question. Dashboard, is the dashboard covering key performance parameters of the or KPIs?
Um, so it does cover actually. Wait a second. I'm not sure if I can show you the report right now. Uh, but yeah, but what exactly the dashboard covers is like, it covers um, several things. So first of all, it collates all the information from Neoload. It capture all the raw data, and then it will provide you a tabular format where it will provide you the response time, errors, and whatever data, whatever raw information we are going to gather it from the client side, right? So it will provide you all those data in a tabular format, and then we are utilizing the app dynamics API. So from that it will collate all the CPU and memory stats, any thread level detail and all, and then it will provide you all those server level information as well. So apart from that, we have provided a graphical representation of all these CPU, like for the whole test duration, along with the memory graphs and all. Apart from that, when you navigate further in the dashboard, right, so it will give you a detailed information about what are all observations it has achieved out of it, or like it has extracted out of it, and then if there are any recommendation, Dipti. We also have given one more feature in the dashboard. Let's say if you have came across any issue, right, so it has a feature where you can directly record it as a Jira ticket, and then from there it can go further for a defect triaging process as well.
Okay, great. Thank you so much, Chandan. Thank you for patiently answering all the questions as well. Srimay, could you
Yeah,
please?
sure, sure, Dipti.
Thank you, everyone.
Yeah, thank you so much, Chandan, for your wonderful session, and it was really informative.